Hello creative friends, in this video we will present our work called Orion-X. Before that, allow us to introduce ourselves. My name is Taqwim.
My name is Firlo Putrawan Parenrengi Daeng Matareng.
We will move to background session. In this sophisticated world, technology is certainly growing rapidly. However, it is possible that these technologies have weaknesses. In the field of astronomy, technology that has weaknesses can potentially endanger the lives of astronauts. So we must develop technology by minimizing weaknesses that endanger astronauts. To solve the problem in the background session is to ensure the safety of astronauts. We designed a project called Orion-X. Orion-X itself is an abbreviation of Orbital Rapid Integrated Outflight Nexus Experimental. The main function of Orion-X is as the last rescue for an astronaut so that he can land safely on Earth. Orion-X itself is a capsule equipped with a parachute that functions to land safely. This capsule will inject the parachute together with the support legs at a certain height. Next, we are moved to a physical and mathematical concept of this product. First, we have Newton's second law. When the parachute is opened, the parachute's body experiences the downward force of gravity and the upward force of air resistance. According to Newton's second law, the total force determines the acceleration is force equals to mass times acceleration. This equation produces a differential equation that describes the change in velocity until terminal velocity is reached a constant velocity when the forces are balanced. Next, we have thermodynamics. According to the first law of thermodynamics, the heat from atmospheric friction must be absorbed or reflected so as not to damage the structure. The material is designed to be heat resistant, not to conduct heat quickly. And last, we have optimization. The design of the thermal tile must also be optimal, capable of retaining as much heat as possible with as little weight as possible. This is where the principles of mathematical optimization are used to find the most efficient material and shape.
Thank you, fellow student Fulky, for your explanation. Now, let me continue our presentation by discussing our project. First of all, previously we would to apologize because due to distance constraints, we were unable to meet in person to do the presentation. Okay, let me start the presentation. So the first segment is design. So our prototype, it has three sections. The first section is the cap segment. So or we can call top section. This section is designed to be released at a certain altitude. Its main function is to deploy the parachute, allowing the capsule to land safely. The second part is the body. This part contains all electronic components that support the system and control the capsule movement, both while airborne and after landing. It also serves as the cabin where astronauts can take shelter. So the last part is the landing legs. So these are responsible for supporting the capsule upon landing. They are deployed using a mechanical system that will demonstrate shortly. Okay, in the real version, this capsule will be made on tungsten metal, which is extremely strong and heat resistant. However, in our prototype, we choose to create a clear structural model that can be easily understood and appreciated by everyone, and that also serves as an education tool. Okay, next, to maintain the capsule stability during the flight, we plan to install fins. So also made from tungsten. So we will install the fins in over here from the tungsten metal. This will help balance the capsule in the air, on land, or even on the water. You may wonder why these are not included in the prototype. The reason is that our prototype focuses visualizing the structure and key mechanism rather than replicating every material component of the real design. Therefore, parts such as tungsten based elements were left out. Additionally, the capsule features automatically flotation device located in landing legs over here. This will inflate if the capsule lands on water. The cabin is also equipped with emergency rations and air pressure stabilizer to help astronauts survive in harsh conditions. Okay, now we move on. The most exciting part is the demonstration. For this demo, we use 2 DC motors and a few microchips to connect the system to a radio controller. For this demo, we use 2 battery over here. So let's start the demo. So first of all, we turn on the system. Okay, we turn on. Okay, first to deploy the legs, so we should to pull this stick. We pull the stick by DC motors over here, and we connect the stick by tail. So we press the button to pull up the stick. Okay, and after that, the leg will launch perfectly right here. Okay, now we must deploy the cap of the rocket. So we press this button to deploy. Okay, the connector will unlink with the body and the cap will deploy, and it will launch the parachute. So overall, we designed the system to be as efficient as possible, using only 2 motors to control both the 4 landing legs, these legs, 4 landing legs, and the capsule. Okay, that's all our presentation today. My name is Firlo Putrawan Parenrengi Daeng Matareng. We apologize for any errors, and thank you for your attention. Bye.